Yesterday we used Blue Canoe to create a realistic model of the Solent. In Pixis we ran two models, a baseline simulation and a simulation with the artificial bramble bank raised. In today's practical, what we're going to do is we're going to use Blue Canoe to do three things. To validate the model against time gauge data, to calculate flow rates through a cross section, and to run a particle tracking model. But in this part we'll focus on the first one. So make sure you've downloaded day 4 and unzipped everything there. And in this first stage, we're going to compare what our first model we ran yesterday, we're going to compare the water level predictions with measured data in the Solent at 5 tide gauge sites: Southampton, Bournemouth, Portsmouth, Sandam and Lymington. And in the process we will look at 5 things. First of all, how to overlay data on a rectified image, extract time series from the model, resample those time series, use the calculator to do things like difference plots, and calculate validation statistics. So let's go ahead and open Blue Canoe. I'm going to maximize it here. And the first thing we're going to do is import. And what we're going to do is import a geo-rectified TIFF. This is something that we've set up previously. Now, my computer's a bit slow, so we might have to hang on a minute. And this image is basically a Google Earth image of the Solent that we've rectified. Rectifying just means you click on each of the corners of the image and you give it the coordinate system so that we can overlay it exactly on top, or overlay a model results exactly on top of this. And it's just a nice way of visualizing the data. It's taking a long time. So we need to go to day 4. GIS, there's the rectified image here. And what we can do is we can just drag this to the 2D view. And there's our nice rectified image. So what we're going to do now is open the model results from what we did yesterday. So we need to go into our practical folder, runs, and it's Southampton Real. And there are the results there. They might take a couple of minutes, couple of seconds to load in. Okay, and like before, we'll just drag in the U and V velocity, right click on it to animate, and then we can run through. And here you can see the vectors coming in here. Now what I'm going to do is just scale it. So I'm going to right click on the velocity, go to properties, I'm just going to scale it to 900. It just makes the vectors look a little bit more sensible. That's okay. And there you can see the vectors. So that's just a nice way of now overlaying the data on a nice graph. Now what we're going to do is import the tide gauge sites, and we've got these in a shape file, and hopefully from Cape Parks many of you have learnt good ArcGIS skills. So let's go back to day 4, GIS, and there's our tide gauge sites there. Okay, and what we can do is drag those tide gauge sites onto the 2D view. We should see those appear shortly. So you can see the tide gauge sites there. But what I'm going to do is go back to the properties. I'm just going to change the size to 10 to make them a bit more clear. And now you can see where the validation sites are. So there's a blue one there, a green one here, red one there, red one there. So there's 1, 2, 3, 4, 5 sites there. Okay, Now what we're going to do is, just have a look at the details of those sites. So we can right click on this and show attribute table, and this just shows the coordinates of those sites and the names. So site 5 is Lymington, Sandown Pier, Portsmouth, Bournemouth, and Southampton. So those are the sites there. Okay. What I'm going to do now is bring in the names of the sites as well, so we can have a look at, we can actually overlay that on there. And what I'm going to do just for a time being is just make the flow vectors invisible. So click on the sites there, right click, properties, and if we go to data, we can actually get to do it against the name. And press OK. Let's just go back to the properties, change the size to 20, put show labels. And you can see now the names have appeared next to the site there. Okay, so what we're going to do now is actually start importing the tide gauge data and comparing it. And I've collected this data from a variety of sources. Southampton I got from contacts at Associated British Ports, who's willing to give me the data for free, although normally you'd have to pay if there's a commercial charge. Bournemouth and Portsmouth I've got from the British Oceanographic Data Centre. They form part of the UK National Tide Gauge Network. Sandown Pier and Lymington were obtained from the CCO, the Coastal Channel Observatory. So again, one of the things when you're doing modelling is you're having to get data from different places. They're all in different formats, and often it's just time consuming to do that. But what we're going to do now is extract the model time series at these 5 tide gauge sites. So what we want to do is click on Free Surface, go to Tools, and go Extract Time Series at Multiple Points. And we're going to select those 5 points that we've just loaded in, the tide gauge Southampton, the tide gauge sites. Okay, and what we should see now is that our data appears in this table. Now, in order to actually get those out, we need to right click on it and extract time series. And what you can see is it's extracted our first time series there. And we can create a new 1D view and just have a look at that time series. We drag it to it. So there's our time series there. So this shows the predictions at Southampton over a 15-day period. In order to extract the second site, we just need to go back to here, right click and go Properties, go to Data and select our second point, Apply. Then we can go Extract Time Series. There's our second one, and basically we want to repeat that until we've got all 5 sites. So I'll just do that quickly. Go to Properties, Data, the third one, Extract Time Series, fourth one, Properties, 4, Extract Time Series, Properties, 5. Extract Time Series. So there are our 5 points there. Now, rather than using these, which are a bit confusing, what I'm going to do is actually, well, you can either right click or double click on the properties. What I'm going to do is actually change the name to Modelled Southampton. And I'll do this for all of them, just so it's much easier later on when you come to compare the data. They're much easier to find. So we'll do Bournemouth. The third one is Portsmouth. Sandown. And finally, Leamington. Okay. Now what we're going to do is, if you go back to the data here and have a look, what you can see is that the start of the data set is poor, and that's because the model is warming up. And this period should really be removed. We don't want to compare this period with observations. So what you need to do is right click on each of these time series. I'll start with Southampton, and we can go resample. So click on the resample there. And what I'm going to do is just change the date here. So I'm going to change the start date to actually the second day. So I'm just going to remove all of the, just remove the first day. Okay, and I can click OK. And we can do that for all of the other sites as well. So we ignore the first day. And this one here contains that resampled data. Okay, now we're ready to actually compare with the measurements, the measured data. And so what I'm going to do is load that in. So if we go File, Open, go to day 4, now click on the validation folder, go to all the files, and what we're going to do is load in the Southampton time series here. It's a TS1 file. So let's bring that in there, and you can see the data is down here. Now again, just to be consistent, let's double click or right click on it and change the name of this now to Measured Southampton. So now we have the measured and the modelled data. And what I'll do as well is resample that, because this has a slightly different data length. So right click, resample to the model. So let's change that to 02, like we did before, 12 o'clock, so when the model starts. Now you can see this data is for the whole year, but actually we only want to compare with January. And in fact only the first 15 days. So we can change that to 16 there. So it's the second to the 16th, 15 complete days. Okay, and that's the resample there. Now what we can do is bring that, let me just delete this, remove this Leamington. Let's plot the resampled Southampton model data and the measured data here. Now what you can see is that the measured data is much higher. And the reason why that is, so there's a 2 meter offset, and the reason that is that the modelled time series, the red, is relative to mean sea level, which is approximately the same as ordnance data mean. Whereas the measured data is to chart datum, and chart datum is lowest astronomical tide. Therefore we need to convert the measurements to chart datum. For Southampton, to get from chart data to ordnance data, you minus 2.74 meters. And the National Tidal and Sea Level Facility website lists the chart data for key sites. Or you could go to Add Multi-Timetables to get this information. So what we're going to do is click on the resampled measured Southampton data, go Tools, Calculator. What I'm going to say is A is the resampled measured Southampton data, that one there. And in terms of my expression, it's just A minus 2.74. Obviously, if you're doing this for another site, put in the correct. So here what I'm going to say is, just to be consistent, I'm going to call it resampled measured Southampton ODN for ordnance data unit. I'm going to put in meters there. And we're going to evaluate that now. Now if I remove the measured data here, remove the green line, and now bring in the ODN, what you can see is they overlay on top of each other. Now what I typically always do is I always have modelled as red, measured as blue. I don't know why, but I've always done that, and it's consistent. And what you can see now is that the model's actually doing a reasonable job. It gives us a sort of visual indication of how the model's doing here. We can always go to properties and change some of the other features. So in terms of the Y, I'm just going to round it so it looks better. I'm going to go from 2.5 to 2.5. So I cover. So there you can see the full extent of the data. Okay, now to get a better idea of how well this is doing, what I'm going to do is subtract one of these from another to get a difference. So again, I can click on the resample data, for example, the ordnance survey data, go Tools, Calculator, and because these are the same length now, I can do a difference. So in terms of A, is going to be my resampled measured ODN. My B is going to be my resampled model Southampton. And I can just say A minus B. A minus B. And I'm going to call this Southampton difference. Call that. There we go. Evaluate. What I can do is I can do a new 2D plot and bring in that difference. Sorry, new 1D plot. And there's the difference there. And what we can do is sort of put these side by side and just compare them. And we can get a feel for so certainly at the neat tides it's doing very well, and there's the differences are relatively small. And typically I just plot differences in black. So there you can get a feel for sort of how big the differences are. Now all of this comparison so far has been visual, but as I'll go over in my validation lecture, it's very important to actually quantify the differences. And there's quite a nice tool that you can use. So if you click on the resampled measured Southampton data, click on Tools, and then Time Series, we can compute performance statistics. And what we're going to do is compare the measured data with the resampled modelled data. If we click OK, we get a list of different errors. And I'll go over these all in my lecture, but the root mean square error basically says on average the time series currently are 20 centimetres apart. The R squared, 9.6 between the two, the correlation is very good, and there's various other measures there that we can talk about. It gives you also the differences, so at the moment we're just focusing on January. Okay, now what I'd suggest you do is repeat all of those steps and compare each of the other sites and put together a table with the key RMS, R squared and bias differences to get a feel for, is the model performing well over the 5 sites, which site is doing the best comparison. Now also you need to be a bit careful in that we've compared measured data to the model, and measured data includes both the astronomical tide but also the surge, the weather component. So what you should do really is undertake a harmonic analysis on the measured data just to predict the tide and compare that, so because our model doesn't currently have wind. Okay, that's the end of the first part.